Most of us think of a volcano as a simple, conical mountain spewing red-hot rock into the sky, but that image only covers a fraction of the reality. Our planet hosts anomalies that erupt pitch-black lava, bleed electric blue fire, and shoot raw diamonds from hundreds of miles below the surface. Geologically, Earth is a shifting palimpsest of landscapes. Unlike the Moon, which is a cold, static companion, the Earth's lithosphere is constantly being compressed, scorched, and baked from within. By tracking the 10 most bizarre volcanic rule breakers, we can map the specific forces that dictate whether a planet remains a barren rock or becomes a home for life. At number 10 is Cerro Negro in Nicaragua. Its slopes are coated in thick black ash from a 1999 eruption. Today, hikers climb the cone to slide down the 60-degree pitch on wooden sleds, reaching speeds of 40 miles per hour. While Cerro Negro is used for recreation, number 9, Mauna Loa in Hawaii, serves as a testing ground for extreme survival. At 8,200 feet, the volcano's slopes are so isolated and barren that NASA uses them to simulate Mars. Scientists are locked in a small dome for up to a year, never leaving the habitat without a pressurized suit. These slopes provide a rare physical proxy for other worlds, yet the most significant data points come from the volcanoes that directly alter our atmosphere. Number 8 is Mount Erebus in Antarctica. Despite freezing temperatures at the surface, it houses a permanent magma lake burning at 1,000 degrees Celsius. This lake releases a steady plume of gas on a 10-minute cycle. As magma blobs rise from deep in the chamber and reach the surface, they release bursts of water vapor and sulfur dioxide, essentially letting the volcano burp. Number 7, Mount Tambora, shows what happens when that gas release scales up. In 1815, Tambora produced the largest eruption in recorded history, ejecting so much ash and aerosol that it darkened the sky for months. This triggered the year without a summer. Global temperatures dropped, causing massive crop failures in North America and Europe, and demonstrating how a single eruption in Indonesia can reshape human history on the other side of the planet. Number 6 is Mount Qingbai. Its millennium eruption in 946 was so violent it blew off the mountain's entire summit. Today, a massive caldera called Heaven Lake sits where a 4-kilometer-high peak once stood. To monitor what's happening beneath the lake, geologists use seismic tomography. By measuring how earthquake waves speed up or slow down as they move through the mountain, they can map the cooling but still active magma chamber miles below the surface. These features prove that a volcano's impact isn't just measured in local lava flows, but in its ability to dictate the chemical balance of the entire globe. At number 5, Kawah Ijen in Indonesia breaks the rules of chemistry. Its crater contains a hyperacidic lake with a pH level similar to car battery acid. High-pressure sulfur gases escape from vents along the lake's edge at temperatures up to 600 degrees Celsius. When they ignite, they produce electric blue flames that can reach 5 meters high. Local miners enter these toxic clouds daily, using ceramic pipes to condense the gas into pure sulfur, which they then chisel away and carry out of the crater by hand. Number 4, Cavachi, is a submarine volcano in the Solomon Islands. It is usually erupting, spewing hot ash and acidic water into the surrounding ocean. When scientists dropped cameras into the crater in 2015, they found scalloped hammerheads and silky sharks actively thriving inside the volcanic plume. These animals appear to have adapted to an environment that would be fatal to most other marine life. Number 3 is Ol Doinyo Lengai in Tanzania. It is the only volcano on Earth that erupts carbonatite lava. It's thin, black, and flows at temperatures of only 500 degrees Celsius, half as hot as typical red lava. When this lava cools, it turns into a silvery white ash rich in sodium and calcium. This ash provides the specific nutrients that allow the Serengeti to flourish, supporting the massive wildebeest migrations that depend on calcium-rich plants. Number 2, kimberlite pipes represent the deepest eruptions on the planet. Most volcanoes draw magma from the upper mantle, but kimberlites originate over 400 kilometers below our feet. This magma shoots toward the surface at 250 kilometers per hour. It passes through the diamond stability field, where carbon is crushed into gems, carrying diamonds to the surface in just hours. This rapid ascent leaves behind a carrot-shaped geological pipe filled with solidified kimberlite rock. In South Africa, miners have followed these pipes hundreds of meters into the ground. They are mining the remnants of an eruption that lasted only a few hours, but reached deep into the Earth's interior. Finally, at number 1, we leave Earth for Pluto. Data from the New Horizons spacecraft reveals Right Mons, a dome-shaped feature 4 miles high. Right Mons is a cryovolcano. Instead of molten rock, it extrudes a slush of water ice. Because there are so few impact craters in the region, geologists estimate these ice eruptions occurred within the last few 100 million years. Whether it is a slurry of ice on a dwarf planet or a surge of carbonitite in Africa, these anomalies show that volcanism is the primary mechanism for moving material from the interior of a world to its surface. These 10 sites demonstrate that volcanoes are not just sources of destruction. They are the delivery systems for the calcium that feeds the Serengeti and the carbon that builds our atmosphere. Over geological time, seemingly improbable events become inevitable. Continents drift and mass extinctions occur when an asteroid or a volcanic surge disrupts the planet's equilibrium. Studying these explosive outliers provides a perspective on how rare our current period of stability actually is. It reminds us that our place on this planet is both precarious and potentially fleeting. We only get one history written in the rock. We are temporary residents on a planet that is constantly and violently rearranging itself.